Right, well, good afternoon and welcome. So my name is Simon Ritter. I work for Azul Systems as our Deputy CTO. And what I'm going to talk about now is the idea of faster data with faster Java. Now, the first thing that I want to ask people is, who here has heard of Azul? Okay, probably less than half the audience. Okay, which is kind of what I expect, really, because we're quite a small company and not everybody has heard about what it is that we do. So we are a company that is focused purely on Java. That's all we do. And I'm going to talk about the sort of two things that we do, specifically the one that we do around making your Java run faster without having to change any of the code that you've written and without having to even recompile your code. And just a sort of a little bit of a background, because it's quite interesting. We've been around since 2005, and even though we're still quite a small company, and the people who started the company, their goal was to solve the problem of garbage collection in Java environment. And their initial way of doing that was with hardware, and they actually made their own chips. The original people were chip designers. And after a few years, they discovered that making your own chips is very expensive. So they decided to switch to a software-only solution, and that's what we've been doing for about the last 12 years. As I say, there are two distinct products that we have. One is a straightforward replacement for the Oracle JDK, Java environment, and the other is our high-performance JVM. If we look at those in a little bit more detail, the first of those is called Azure Platform Core, which, if you're running Java and you want to keep that Java up to date in terms of security patches, in terms of bug fixes, then what you're going to do is keep installing the quarterly updates. But where do you get them from? Now, in the past, Oracle and Sun Microsystems before that made the Java environment free. So you just go to the website, you download the update, install it on your machines. For the last few years, Oracle have changed the license so that now if you want to use older versions of Java, like Java 8 or Java 11, then you need a license from them for support, and that costs money. What we can do, because Java is open source, is provide you with an identical service. So you get the same updates for the same versions of Java. In fact, we can support older versions like Java 7 and even Java 6. And we'll do that at a lower cost than Java. So it's a straightforward swap and a license saving cost. The other side of the business, as I said, is around higher performance. So what we're doing here is looking at how can we change the way that Java works, but without having to change the applications that you've written. So it doesn't require any recoding, doesn't require any recompilation. You just change your Java environment and things will run faster. And we do that through a number of different ways, which I'll talk about as we go through. But essentially this is based on top of OpenJDK as well, the open source of Java. And what we find is that by improving the performance of your applications, if you're in a cloud environment, for example, where it's a utility-based pricing model, then by improving the performance, you can reduce the size of the instances you need, maybe the size of your cluster, and that leads to a cost saving in terms of your Java environment and your cloud bill. We have lots of customers. Even though many of you have not heard about us, you'll notice that on this slide there are lots of people that you probably have heard of. And as I say, they're all using our Java environment, whether it's the standard build of Java or whether it's our high-performance JVM. And again, if you look at the statistics on that, over a quarter of the Fortune 100 use us, half of the Forbes top 10 world's most valuable brands use us, and 100% of the world's top trading companies. And that's down to the way that the performance works from a latency perspective. And I'll get into that in a little bit more detail in a moment. So let's talk about Azure Platform Prime and what does it actually do? How do we improve the performance of Java without you having to make any changes? The interesting thing here is you have to look at the way that Java works. Java is one of the most popular platforms for deploying applications on, and has been for the last 20 years. If you look at all the surveys, it's always in the top 3 most popular platforms. One of the reasons for that is because it is a managed runtime environment. It delivers a lot of the functionality that you as a developer would normally have to do yourself. Memory management, creating objects, freeing up the memory, you don't have to worry about that anymore. But that comes with a cost. And so there are 3 distinct areas that we need to look at from a performance perspective. The first of those is latency. How long does it take for a transaction that you want to initiate to come back and complete? One of the biggest impacts on latency from a Java perspective is the way that memory management works. And we have this thing called the garbage collector. What that does is it periodically goes through the memory looking for objects that are no longer being used. Where it finds those, it can reclaim the space used by those objects and make it available for new objects as the application continues to run. That's very important because if you don't do that, you effectively get a memory leak and you run out of memory. So the way that works in most algorithms is that to do it safely, because you're going to need to find all the objects whilst the application is running, and then potentially move them around within memory to eliminate fragmentation. The way that most algorithms do that is by pausing your application so that it can't make any changes whilst we're doing the garbage collection. So that leads to latency because of those pauses while your garbage collector is running. The second thing we need to think about is throughput. How many transactions per second can we handle for our Java application? Now, Java, being platform neutral, write once, run anywhere, doesn't use compiled code which is compiled into the instructions of the particular platform you're running on. It uses what are called bytecodes. They're a virtual machine instruction set. When you run your application, those bytecodes have to be converted into the necessary instructions for the platform, whether it's Intel, whether it's ARM, Windows, Linux, or whatever. That happens in a couple of different ways. It happens through interpreting, which is very slow, but then to speed things up, we do just-in-time compilation, JIT compilation. We compile the code as the application is running. How well that works will determine how many transactions per second and what throughput we can get for our application. And then related to that is the idea of warm-up. When your application starts off, it's going to start slowly because it's interpreting bytecodes. We need to find the frequently used pieces of code and then compile them to get the best possible performance. That takes time. And one of the drawbacks of that is that every time you do the same thing with the application, so you start it up again, you lose all the information you have from any previous runs. So you go through the same process of identifying code, compiling it, and so on. If we look at a typical performance graph for a Java application, this is what you're going to see in terms of how your application runs. It's going to start off slowly because we're using bytecodes, we're using the interpreter. Gradually, the Java virtual machine will identify which pieces of code need to be compiled. It will compile them in different ways and then make the code faster and faster as all the frequently used pieces of code are identified. So over time, we get to this steady state where we've compiled all the code that we need to make our application run. How long that takes is the warm-up time. And that could be a few minutes, it could be a few hours. In extreme situations, it could take days for that application to warm up. The other thing you're going to see is some dips in performance even when we've got that fully warmed up application. And that's down to the idea of these garbage collection pauses as the application runs and space needs to be reclaimed to keep it running. What we at Azul do is to change the way these particular things work within the JVM. And the graph now looks very different. The graph is the dark blue one. What we can see here is the effect of three different things. Firstly, we can eliminate all of the pauses associated with garbage collection because we have a different algorithm called C4, the Continuous Concurrent Compacting Collector. That is fully concurrent, meaning that we don't need to pause the application whilst we're doing the garbage collection. But it's completely safe, so there's no danger of losing changes or missing links to objects and so on. So we can garbage collect without pausing your application. That's the first thing we do. Second thing we do is to replace the way that some of the compilation system works. We have a new version of the compiler called Falcon. That's based on another open source project called LLVM. Rather than compiling code in the way that the Oracle JVM does, we use a different approach which can identify more situations where we can optimize in a better way. We can take advantage of the way that the processor works and more modern processor features, things like vector processing, that enable us to handle multiple elements at the same time and do things in parallel. What that does is to raise the overall level of performance so we get faster code even though we don't change any of the code. And that gives us higher throughput. So now we've eliminated the latency problem, we've eliminated or made better the throughput of our application. And then the last thing we need to look at is the idea of how to reduce or eliminate as far as possible the warm-up time. And that's what we do with a technology we call Ready Now. You run your application, you let it warm up, you let it run in a production environment, and then we record a profile of that application. That stores all the information about what code has been compiled, what classes you're using, and so on. When you start the application again, rather than having to identify all of these things, recompile all the code, we can use that information from the previous run and straight away say, right, we need these pieces of code compiled, we've already done it, reuse that code, and we get much, much faster startup and warm-up time than you get if you're just using the standard hotspot compiler. To give you an example of how we can eliminate latency, what this is showing is, on the left-hand side, a graph of Elasticsearch running an application. And we've got 128 gigabyte heap, so a reasonable amount of data. If you look at the line on the left-hand side, what that's showing you is the impact of the Java runtime on your application. So not the latency of the application, the latency of the JVM. We see a very typical graph here. There's lots of small spikes, which are minor garbage collection pauses. And then a couple of big spikes, which are major garbage collection pauses. If you look at the line on the right, what that shows is what we can do with Platform Prime, or as we used to call it, Zing. And you might look at that and think, well, higher is bad, so surely what you're showing me doesn't show any improvement. And I've been deliberately misleading here, because what I've done is to scale the graphs differently. Graph on the left is 0 to 8 seconds. So we got lots of pauses in about half a second, and then a couple of big pauses around 5.5, 6.5 seconds. On the right, I've scaled it from 0 to 80 milliseconds. So that's a much lower scale graph. If I change the scales to be the same, you see the effect. All those garbage collection pauses just disappear. So latency is eliminated from the point of view of the JVM. And that's one of those key things, is how to improve the performance of your big data applications is by eliminating that latency. I'll just talk about a couple of case studies of real customers, because it's all well and good showing these sort of performance graphs and how things might work. But what about people who are actually using this software in production? We have lots of reference customers. What are they doing? So the first one is a customer that I can't actually name on the slide, but they're a customer who are using a very popular JVM-based platform and framework called Kafka. So I'm sure you've heard of Kafka. Kafka is very frequently used in big data applications. Now, what they had to do was they run a security-based solution, and they have a lot of Kafka-type interactions, so 2.5 billion messages daily across their cluster. And initially, they approached us about the problem of latency. They wanted to solve the garbage collection pauses, and they looked at our product to do that. What they found was not only could they solve that problem of latency, but then suddenly they were getting 20% more transactions through each node in their Kafka cluster. And they could support a much higher number of transactions. What that led them to was a 15% saving in terms of their cloud bill. So they got rid of the latency as one aspect, but then they also reduced the costs of running that application. Another customer that we have, MasterCard. These people really know about big data. So their fraud detection system is using a lot of data. So they have like sort of in the terabytes of data. And the problem they were facing again was this idea of garbage collection. And they were seeing over 10,000 full garbage collection pauses every day. And when you're trying to do fraud detection and you want to be able to provide a result, you know, within hundreds of milliseconds because somebody's put a credit card on a machine and you need to determine whether that's fraudulent or not, you can't be waiting 5, 6 seconds or a minute for that information to come through. So they were able to eliminate all of that problem by switching to using our platform Prime, and all of those GC pauses just literally disappeared. And then the last one that I want to highlight is a company called Taboola, who are an advertising platform. But once again, very big data in terms of the amount that they're dealing with. So 1.4 billion people every month for their advertising platform. And they do 30 billion recommendations every day. All of their core applications, their database, and many of their smaller applications are all Java-based. So they've got thousands of servers to support this number of transactions. When they talked to us, they said, right, we've got a monolithic billing system with a terabyte of heap, which is a big amount of data. And they're running on the Oracle JDK, but again, lots of GC pauses. After they installed our product, those pauses literally just disappeared again. So once again, we were able to solve the problem of garbage collection, eliminating the issue of latency. Then, and these are quotes directly from the people who run Taboola, they said that they literally say that they're able to achieve unobtainable technical feats with our platform. That's really good to see one of our customers saying that. And they said the ability to provide services with a smaller IT footprint and serve the clients faster, fewer errors, means the efficiency goes up while the spending goes down. And then the last bit that's really important was the fact that they could reduce the number of servers and the footprint by more than 30%. And if you've got thousands of servers in your cloud environment, 30% of that is a big number. And it's a big reduction in terms of the cloud bill. And even their database footprint, again, they were able to reduce that by 50%. So very significant savings by simply changing the Java environment that they were using. And again, I'll say that remember that it doesn't require any changes in terms of your code. It doesn't require any changes in terms of recompiling your code. It doesn't even require any changes in terms of the startup scripts. All you do is switch to where the new JVM is. Just to summarize then, basically the idea about what we're doing is delivering faster Java with Azure's platform Prime. Lower latency is the key thing. We can eliminate the issue of garbage collection. Reduce your cloud infrastructure costs by managing the platform, looking at the way that the code works so that we can deliver higher performance for the same code, therefore a higher number of transactions per second, less resources needed for running your application. And it's important to show as well that with these examples I've given, that it scales up to really anything that you can think of in terms of internet scale. people like MasterCard, people like Taboola, terabytes of data that they're processing without any problem. If you're interested in this, we do have a free trial. You can go to our website, you can download it. As I say, it is just a JVM installation. You don't have to do anything special. One thing I would say, which I haven't mentioned already, is it only runs on Linux. Because of the way that we do memory management at the operating system level, it only runs on Linux, but for most people that isn't a problem. As I said, you can download it from our website, install it on your system, try it, see what you think. If you need some help, we have our SEs who will very happily help you, especially with the testing and generating results, so you can see the difference, those graphs I showed you, between what you have with Hotspot and what you get with Platform Prime. And so with that, I would like to say thank you very much. If anybody has any questions, you can either ask me after, or I'll be on our stand at the end later on as well.